So this lesson, 2.4, was actually added to the Algebra 2 curriculum because of what shows up on your SAT test. So this summer, the Algebra 2 teachers decided that we haven't seen this topic since like Algebra 1. It's been a few years. So the first bit of notes here, this is a review for you about what lines look like when you graph them. So remind me, when we have a horizontal function, a horizontal line, this is called a constant function. And an example of a constant function would be anything in the form y equals a number. So like y equals 2, or y equals 5, or y equals negative 1,000. All of those would be constant functions. What does the graph look like, though? It's going to be a horizontal line. So whatever that value is, it's going to be a horizontal line through that value. Very good. So the buddy to that would be your vertical lines. You have a vertical line. It represents all the places where the independent variable is always a specific number. Indent. You can't spell independent. All right. So it is the x value, yes. So they're in the form like x equals 2 or x equals negative 3. Whoops, that's a negative. Either way, what does the line look like, just in general? Up and down vertical line. Okay, so something like this. Now, bad news. All of our work today and tomorrow's lesson, it's going to be applications of linear functions. There's very few applications in the real world that produce vertical and horizontal lines. So our focus is going to be on the slanty lines, the normal lines that you guys are used to, which are known as transformations of the identity function. This is the identity function, but the line that you guys are most familiar with is this guy, y equals mx plus b. Sound familiar? This next form, though, this one might not be familiar to you. I'd like a show of hands once I write it down, and I want to see who has ever seen this other form before. It's called point slope, and it's y minus y1 equals m times x minus x1. Anyone ever seen that before in their past? Okay, cool. So, geometry? Or, oh, cool, great. That's wonderful news. Yay, geometry. All right, so slope. Which one of these variables represents slope? Yeah, m. Why is it m? I don't know. Because we're America and we call it m. We're the only country in the whole world that calls it m. A, or their equivalent to A in their alphabet. Because they go alphabetically. They go A, B, C, D, E, or whatever their equivalent is. Not us, though. We go m. All right, so the y-intercept. Which one of these variables in one of these equations represents the y-intercept? The b. The b. The other one doesn't have a y-intercept, and that's because sometimes we don't know the y-intercept in our clues. Sometimes we just have what's called a random ordered pair. So in real life, sometimes you don't know where you started, but you know some ordered pair. So notice in this point slope form, which is what this one's called, if you have a random ordered pair, you can place it straight into that question. Now notice what this question does, or this formula does have, though. It does have a slope. So today and tomorrow, here's the challenge. They're going to be word problems. And we know the thing about word problems with math is it's very rarely the math is the problem. It's the reading that's the problem. So you have to kind of interpret the question. They're never going to come out and say, hey, here's slope. You're supposed to know that they're talking about slope somehow. So here's some phrases that you're going to see when they're referring to slope. You're going to see things like average rate of change. You're going to see things like constant change. You might see some phrase that says like change in, and then something like change in height, change in money, change in time. So what do you notice is the same there? Change, change, change. So anytime you see a changing variable, that's associated with slope in these questions. And then the y-intercept, which is our b value, you're going to see phrases like starting point. Or you might see begins with. Or good old starts with. So they're never going to come out and say, hey, by the way, this is your y-intercept. You're supposed to know. And that's half the trouble. So, you guys already kind of answered this for me. But right here it says, sometimes your problems involve constant rate or speed, which is representative of your slope. And then it'll talk about a beginning amount, which is representative of your y-intercept. So they just want you to fill in those words right here, where m represents the slope and b represents the y-intercept. So here's what's great about math. There's not many things, but this is a good one. When they name something, they name it for what it is. So if you have a slope and a y-intercept, they want you to use slope-intercept form. That's what it's asking you to do. So this question, if you can find the clues, they are telling you slope and y-intercept. So let's start reading. We have an airplane that's 30,000 feet above the ground, and then it begins its descent at a rate of 2,000 feet per minute. And then it's going to continue on this trajectory, and then they want me to write an equation. So let's start with this clue about it being 30,000 feet above the ground. What is that? Like, as far as my linear equation goes, I told you we're looking for two things. I'm looking for slope and I'm looking for y-intercept. This is the y-intercept. This is where it starts. So you can call it b if you'd like, but it's the y-intercept. And then there's another clue. It says it begins descending at a rate of 2,000 feet per minute. What's that? Good, that is slope. What is the slope? Okay, 2,000 over 1 I heard? That is really, really wrong. Thank you for saying it, though. But thank you, because I was hoping someone would say that. Because all day, that's all the kids have given me, 2,000 over 1. So then I said, okay, so your plane is going a rise of 2,000 feet every minute. Oh my gosh, so not only do we have to read like implied things all of a sudden. The fact that it's descending. You're supposed to remember that that means negative. Now, when that shows up on your test, and it will, I bolded the word descending or underlined it or something, so hopefully that reminds you that it's negative. Sorry, that was really aggressive of me. Alright, so we have slope, we have y-intercept. We're able to write the equation, but not yet, because we got to figure out what the x and y represent. So I did like how you wrote the slope as a fraction. You says negative 2,000 over 1. And then the label here says feet per minute. Can y'all talk about slope for a minute? Slope is the change in y over the change in x. The label that's put on your slope from the problem is telling you what to call x and y. So right here, y is measuring the feet. Think about this problem, guys. What would you call it for the amount of feet that your plane is in the air? What's another way of saying that? No pilots out there? Altitude? Is that a word that you would use to represent how high up in the air your airplane is? So y, if you put number of feet that the plane is in the air, I totally know what you're saying, but like a human would just say it's the altitude. And then give me a label on that, please, feet. So in the denominator of this label, it's measuring change in minutes. So x is representing the number of minutes. So technically speaking, if you want to be real thorough, you'd say it's the number of minutes that the plane has been descending, because it's going to be in its descent for a while. Okay, you already talked to me about this, guys. What was the slope again? Negative 2,000 feet per minute. Notice I'm labeling our slope. And the y-intercept was 30,000. And then label it, please, feet. All right, we're ready to write the equation. I'm going to write it down here, though. I'm out of room. The equation says y equals slope. What was slope? Negative 2,000. And then we throw an x after that. And then plus our starting value. What was our y-intercept? 30,000. So there's your equation. And now what's good? What good is an equation if we're not going to use it? So take your equation and find the altitude of the plane after 5 minutes. So remember, minutes is the x value. So they want you to plug in x equals 5 into your equation. So this could be on your home screen of your calculator, or you can use the old noggin today. Negative 2,000 times 5. plus 30,000. What is that, 20,000 feet? And I know this was kind of like a lame example because planes don't fly linearly, so it's kind of a stupid example, but the idea is the same. If the control tower is trying to manage like all these airplanes and they're noticing that flight 413 is not at the proper place in their descent right now, they have to either adjust their flight plan or they have to get them back on track because they're going to overshoot or undershoot the runway or they're going to crash into another plane. So these are all things that they got to think about. Anyone interested in being an air traffic controller? That is an amazing job that pays a ton of money. You actually are forced to retire like in your way before retirement age because no, it's incredibly stressful. They make you retire before you're 40 with full benefits. No, not that. No, I'm talking about the people up in the tower. Oh, no. I mean, these probably pay lovely too. No, I'm talking the people up in the tower. If you are interested in that, it's an amazing job, by the way. Very stressful, though. Incredible amounts of math. So those of us who are like, I don't want to take a 4th year of math. No, big math in your future if that's your goal. All right, let's get one more done, guys. This one won't take us as long because we got the gist of this one. Okay, you received $100 as a graduation present. What is that? That's our starting value, right? That's our Y-intercept. And then because you're a super saver, you're going to put away $5 every week. What is that? That's your slope. So to give it a label, that's $5 per week. Keep that in mind. Identify the variables. Well, the slope label is what's going to help you with the variables, guys. Remember, slope is the change in y over the change in x. So x is measuring weeks, so I'm going to say that's the number of weeks. And then the y is measuring how much money you have. So what would be like a human way of saying how much money you have in your bank account? You can say amount of money in your bank account. That's fine. Is that called anything? Balance. Thank you. Some of us have negative balance, yes. No judgment. All right, so slope. This time, guys, you're adding to your bank account. So are they trying to be sneaky where I'm supposed to remember magically it's negative this time? No, this time it's just slope of $5 per week. The y-intercept started us off at $100. All right, time for an equation. So y equals $5 per week plus $100 to start off. Now be careful on this next question. I want to know when you're going to get $310 in your account because I'm going shopping. What variable is that? That's the y value. So you're going to plug 310 in for the y value this time and solve for x. Right, so super solving time. Ready? Subtract 100 from both sides. Get 210 equals 5x. Divide both sides by 5. And I think it's 42 weeks. Notice I keep labeling all my things that I'm finding. Very important in word problems, right? All right, we'll pick up here the next lesson. So the last few questions you guys looked at for applications were all written in slope-intercept form because they gave you clues that revolved around slope and the starting point. But that is not often how real world works. So in the real world application questions, usually you're given different clues. Sometimes you have a point and you have a slope. So if you have a point and a slope, you're going to use point-slope form. So this is written at the front of your packet, but write it again here because this is the formula we're going to be using. I will give you this formula on our test for Algebra 2, but this is not necessarily a formula that you'll have for your SAT test. And good old math, they're naming things for what they have. I am, yes. So the point, there is a point sitting in this formula. Can you find it? It's an ordered pair. Do you see it? It's okay if you don't. I'll tell you, it's right here. This is x1, and this is y1. So the ordered pair, will be placed in the x1, y1 position of that formula. And I think you see slope if you look carefully. Who represents slope in our formulas? M, very good. So once you find your slope and your ordered pair, you can place them there, and then you're going to be able to clean it up and distribute and get whatever form of the equation you want. But of course, like every question we did yesterday, the trouble is not the formula, the trouble is reading through all the words and figuring out what they're telling you. So Marty is spending money at an average rate of $3 per day, and after 14 days, he has $68 left. So find the amount. The amount left depends on the number of days that have passed, and for some reason, this person can't stop spending $3 a day. All right, so X represents, and I will have to tell you this probably on a test, so don't panic about this part, but X is going to represent the number of days. Well, I'll either flat out tell you, like, this is X and this is Y, or else I'll give you a clue with labels. So, like, yesterday we saw clues where I gave you slope, and we paid attention to where the labels went for slope. So Y, let's see, that's going to be the total money, or money left, whatever you want to call it. So somewhere in these words, you see slope. Do you see it? They don't say slope, but they do say something about how things are changing. Right here we have average rate of $3 per day is what they are spending. What is your slope? So I was hoping you guys would say 3. This is that moment from yesterday where I was like, that is very wrong. -3. Good call. -3. Why is it -3? Because we're spending the money. Yeah, so you're losing $3 per day. That's the slope. There is an ordered pair sitting here. If you look closely. 14 days, $68 right there. So now that you have a point and you have a slope, you should be able to put these clues into point slope form. Remember, I will give this to you on a test, but you have to know where the things go. So point slope form says y minus, who's the y coordinate from the point you just gave me? 68, very good. Y minus 68 equals, what's the slope you just calculated? -3. And then parentheses, x minus the x coordinate from the ordered pair. Is that a 14? All right. Now, technically speaking, you would get credit. If this was the question, it said write an equation, boom, you have an equation. But this equation's not really in any sort of a form that I'm happy with. So what most kids do now, and you don't have to do this step, but knowing what comes next in the problem, you might want to, they clean this up. So they distribute the -3. And I'm going to work down here now. So right now they have y minus 68 equals -3x. What is that, a plus 42? And then they're going to rearrange it so it's in slope-intercept form, which is the form that you guys are most familiar with. So they're going to add the 68 over. So this equation, y equals, is that 110? -3x plus 110? This is a great form of that equation. It happens to be equivalent to this form of the equation. Just one's rearranged for slope-intercept and one's not. The reason I wanted you to go through the rearrangement is because look at the follow-up question. It says, use your equation to find out how much money that he began with. There's two ways you guys can interpret this. The money he began with, also known as your starting point. I think you're staring at the starting point. Yes, right there. Remember the y-intercept, the b is the starting point? So apparently this dude started with $110. Another way that you can find the starting point would be to literally plug in how many days have gone by. So when he started his vacation, how many days was he on? 0, right? He hasn't had any fun yet, so 0. So you could plug in a 0 for your x into either of the equations, and either way you're going to get this $110 as a starting point. Okay? So it's all about being fluid within your formulas. You can go from one formula to the other. You know the benefits to using one formula versus the other. Unfortunately, real world, not always so nice. Sometimes they don't give you a slope either. Sometimes all they give you is 2 points. So if you have 2 points, that means you are going to have to calculate slope. So you got to reach way back in the geometry brain for me, guys. Who remembers how to find slope? It is, yes, very good. Y2 minus Y1 over X2 minus X1. Is that the only possible formula for slope?
No.
Could I rearrange the order and still be okay? As long as I remembered to do what? Do I have to keep the same order down here? Yeah. So you can use either one of those formulas for slope. This is usually the formula that kids rattle off to me. This guy right here. Okay. So once you find slope, which you're going to have to calculate, then you get to use your favorite point from your ordered pairs and use point slope form. Okie dokie. If you go overseas and you don't have a international calling plan, you get charged a lot of money for phone calls. Like a lot. So they will usually charge you like a flat fee for making the phone call itself, and then they charge you per minute on top of that. So what we have here is two pieces of information that are going to be ordered pairs, as long as you can identify the variables with me. So let's let X represent the number of minutes. And then Y can represent our total cost. So I don't know about you, but I'm seeing two ordered pairs. Here's the first one. A 5-minute call is going to cost me $5.91. Yeah. You talk real fast with Mom. All right, and then a 10-minute call is going to cost you $10.86. So we have two ordered pairs. I don't have a formula for a line that's called the 2 points form. So what I have to do now is I have to calculate slope using that formula you guys just gave me. So the formula being Y2 minus Y1 over X2 minus X1. Remember that these ordered pairs, it doesn't technically matter as long as you keep your order straight. I'm going to call this X1, Y1, and this guy X2, Y2. All right, here we go. Starting with Y2. You're going to rattle it off, or am I doing this one? You guys are so quiet today. Is it because we're recording? Thank you. Oh, I'm just boring you. That's what it is. Okay. 10.86 minus 5.91 over, thank you, 10 minus 5. Notice how she kept her order the same for both subtraction problems? And then the Meyer method is to calculate the numerator and denominator separately, because when Mrs. Russo does it all in one step, sometimes I forget to use parentheses, which is a big mistake. All right, so your numerator is 4.95. That denominator, 10 minus 5, I got that. That's 5. What does your slope come out to? 0.99. All right. Can you guys interpret that slope for me? Very good. They're going to charge you 99 cents for every minute of your phone call. So then I had a really great question from a kid last hour. They said, well, wait, if they're charging 99 cents for every minute and you make a 5-minute phone call, how is it coming out to $5.91? Well, sometimes it's tax. Not this time, though. So let's continue on to find the equation, and I think we'll see what's going on. Okay, I need you to pick your favorite point. Do you prefer the green point or the red point? Okay. And it doesn't matter. I just was hoping for someone to answer that. All right, so if we use the red point, and we're going to use the slope of 99, now I can throw my information into point slope form. So y minus the y coordinate from that point you guys are choosing, so 10.86 equals, whoops, your slope you guys just found to be 0.99. And then times x minus the x coordinate from that point you're using, so 10. And again, technically speaking, if they just said, what's your equation? This is an equation. That would work. But let's clean up this equation so we can dive a little further. All right, let's distribute the 0.99. I'm going to need some calculator help in a minute here, guys. I'll do decimals in my brain. All right, y minus 10.86 equals 0.99 x minus 9.9. Alrighty, then add the 10.86. So now the equation is in that form that we're used to seeing. y equals 0.99x. Is it plus 0.96? Cool. So you guys already identified for me what that slope meant. You're charging 99 cents per minute for your phone call. So what's this plus 0.96 at the end? Yes, there's some initial flat fee that the minute you pick up the phone overseas, they charge you 96 cents. No matter how long your phone call is, they're going to charge you that initial fee, and then they start charging you per minute. So I don't think I actually answered the question yet. Somewhere buried under all my ink, there's a question that says, what if I only have $12 left? How long can I talk to mommy? Well, it's close to 12 minutes. Let's calculate it. So $12, that's going to go in for which variable? Where does money go, the x or the y? Yeah, it's the y. If you forget, go back up to your variable definition. Whoa, no, come back. Okay, so I don't know what just happened. There. So back to your equation, if we plug in $12 for the y value, you get 12 equals 0.99x plus 96 cents, 0.96. And now I want you to solve. And again, I don't ever want you guys trying decimal work in your head on a test. It does not go well. And this doesn't come out to a real nice answer, which is fine, because this is supposed to be real life, and guess what? Answers don't come out nice. What do you get? 11 point, is it like 1.5 repeating or something? Okay. So think about this in terms of like real life. How many minutes can I talk on the phone before I run out of money? Just 11 minutes, yeah. So the answer here is 11 minutes. And I know it didn't come out this way, but what if my math came out to like 11.9? Could I talk for 12 minutes? No. I'd run out of money before I hit 12. Because money is like a limiting resource in this case, right? So if I don't get to 12, I can't talk 12. Alright, cool. And then for my favorite problem. It's about crickets. This is actually true, by the way. So there's a natural phenomenon that if you count the number of chirps that crickets make when they're outside, it's closely linearly related to the temperature in Fahrenheit outside. So who needs a thermometer when you can just count some cricket chirps? Sure. I think it's cool. You know what, you teenagers? I don't know what impresses you anymore. Right? They don't even know. You just wait till the other examples that come up. All right, so we do have two ordered pairs here, guys, but we have to decide how the variables are set up before we throw down ordered pairs. So let's call x the number of chirps. Technically, it's chirps per minute, by the way. They just measure for a minute how many chirps they hear. And then y is going to represent the temperature. And it's measuring in Fahrenheit. I'm sure there's a way to relate it to Celsius, but we're America and we measure in Fahrenheit. All right, here we go. Do you see two ordered pairs? There's one right here. 124 chirps. How warm is it? 68. All right, so 124 chirps means it's 68 degrees outside. And I think there's another ordered pair that starts right here. 172 chirps is 80 degrees Fahrenheit. So again, I don't have slope, but I can calculate it using y2 minus y1, so 80 minus 68, over x2, 172, minus x1, which is 124. Again, the Meyer method is safer. You guys should calculate the numerator and denominator separately. So this ends up being 12 over 48, which comes out 2.25. So there's the slope. Do you have a favorite point, red point or green point? Green. All right, using this xy, oh, that's blue. Okay, so using this xy ordered pair and using this slope you just calculated, we can throw that information into point slope form. All right, here we go. Y minus the y coordinate, so y minus 68 equals slope, which is 0.25, and then x minus the x coordinate from that point, which is 124. Now, I'm going to show you a little shortcut because there's questions like this on your test where the first question says write an equation. So here it is. And then the follow-up question says, what temperature is it if it's 150 chirps that you're hearing? So what should I do with the 150? Is that an x value or a y value according to how we set this up? Yeah, it's an x value. So you need to plug in x equals 150 right there. You don't have to rearrange the equation first. Eventually you will have to solve and rearrange, but you don't have to do it right away. So y minus 68 equals 0.25, and you guys are plugging in 150 right here. So on your calculator, please don't do this in your head. Crank this whole mess into your calculator. And then the last thing you're going to have to do for me is you're going to have to add the 68 over. And then finally, you know how warm it is outside. This is pretty magical because I think it's close to this temperature right now. Is it 74.5 degrees Fahrenheit? Is it? I don't know. I live in a jail cell, so I don't know how. There could be a tornado outside, and I'm safe. I don't think I see daylight for like 3 months of the winter. I show up at 6:30 and it's dark, and I leave at 6:30 and it's dark. It's very depressing. Okay, Mrs. Meyer, do you want to pass out that practice worksheet for me while I... Yeah, it's a great question. I think it's up there. On top of the silver, or not silver, clear, whatever. Thank you. The reason I want to keep the presentation going, guys, is because there's some SAT questions on your practice worksheet you're getting, and there's one I would like to look at. It's a doozy. So we're going to look at, this is from SAT test number 2. This is on the no calculator section, number 9. So it's about midway through the test, for the no calc test. The graph of a line in the XY coordinate plane has a slope of 2 and contains the point 1,8. So right here, you got a clue about slope and a point. That feels a lot like what we just did. And then there's another line, and the clues they give me here are that it goes through these 2 points. So again, that feels like a lot like what we just did. So what's going to happen is if we were to graph these 2 lines on the same coordinate plane, they're going to intersect at some point, and they're calling it AB. So wherever they cross, they call it AB. And they want you to figure out the value of A plus B. So like whatever this is plus whatever this is. Well, this is a super fun question. Can you say with confidence that you're going to roll into your SAT test and have all these formulas we're about to use memorized? No. That's okay. I appreciate your honesty. And you know what? And remember, you're going to be really panicked. There's a good chance that you swear that you will have that slope formula memorized, and in the middle of the test you'll be like, oh my gosh, is it x over y or y over x? Oh my gosh, like you'll freak out. So we need a backup plan. And my backup plan is I'm going to recognize this to be a coordinate geometry problem, which means I should be able to draw a picture of it. So I think we all know where this is going. I can't draw. So if I'm going to use this method, I'm going to have to focus and do the best drawing that I could possibly do. Beautiful. Okay, now you do the same thing, guys. Draw yourself a little coordinate plane. You might want to put down some tick marks that count like a few units right, left, up, down. And obviously time is of the essence, so if this is your method, you might want to not spend the first few minutes of your test doing it and maybe save this for the end. Oops, that got crooked. That's okay though. So let's talk about these blue clues. No reference to Blue's Clues. You're singing it. I know you're too mature. Alright, so did you know that you can graph a line that doesn't have to start on the y-intercept? It can start at any point they give you. So let's start our line at 1, 8. Well, I got bad news for myself. I didn't graph all the way up to 8, so now I got to pretend. 1, 2, 3, 4, 5, 6, 7, 8, sure. Okay, so there's 1, 8. And my slope is supposed to be 2 over 1. So normally I'd be like up 2 over 1, but I'm going the wrong direction. So instead of up to right 1, let's move down to left 1. I don't even know where I'm at anymore. See, and this is where Abruzzo is failure at this method, because 1, 2, 3, 4, 5, 6, 7, 8. There we go. So 1, 2, boop. 1, 2, boop. All right, so there's the blue line. Let's talk about the green line. I can plot the points and make a line with 2 points. So 1, 2, and 2, 1. Oh, man. Okay, so I didn't say it'd be a great line. Can you guys estimate where you think it crosses? And maybe with your stellar artistic job of graphing, not mine, maybe you know exactly where they intersect. Anyone think they know what that ordered pair is? Was it? -1, 4? Okay. If we think it's -1, 4, and this is A and this is B, and they want you to add these numbers together, what would that come out to? So Sierra's hypothesizing. She thinks it's 3. You're right. That is the right answer. But let's talk about how maybe I finished the test and I notice on the clock I have a few minutes left, and I'm not real certain that I did this problem right. Guys, it wouldn't have been that hard to figure out. It just would have taken actually a lot more time than the graph would have taken. So you would have started by plugging into point slope form. So y minus the y coordinate equals slope times x minus the x coordinate. And then with these 2 ordered pairs, you could either find the line like we did on our notes, or I do have kind of a decent drawing over here, guys. Can you tell that the slope is -1 and the y-intercept crosses at 3? So the green line looks like this. And then to figure out where these intersect, guys, that's a system of equations. That's what we just got done doing. So you could use the substitution method where you plug this in for y, and then you can solve an equation. So you tell me, which way do you think was easier, the graphing way or the algebra way? Graphing way is much easier, much quicker too. Of course, you have to be able to graph in a straight line. So you live with what you got, guys. Okay, so you have 3 SAT questions. They are much, much, much easier. They're actually some of the easiest questions I've ever seen on an SAT. I know they have a lot of words, but you got this. Those SAT questions are good. On the front of the worksheet, you have 3 questions that are inspired straight from our notes. So as you guys are working, I'm going to leave the airplane question up from our notes because that's going to help you get started on the very first question in your homework assignment. Okay, so not on the SAT side, but on the other side. All right, video out.